Hi, hello. I'm Kemel and this is Kem with Kim. Now, in this session, we are going to be working out we're going to be doing a partial work through of the January 2024 sitting of chemistry paper 2. That's a mouthful. I think I got it. So we're going to work one question this evening and we're going to post, and based on your feedback, we will consider working the other questions. All right, you can use this as a means of practicing, just checking to see how you're progressing. It's always good to check to see how you're doing, especially when your exam is in a few weeks. So let's get right into it. Let's just look at the layout of the paper. Now, many things haven't changed. One of the things that has not changed is that question one of the paper is a data analysis question, which you'll get 25 marks from. So that has not changed. All right, so let us go and look and see what we have waiting for us. All right, so question one, as I said earlier, true to form, data analysis. It's like you're in the lab for this one. And the recommendation is that you do not spend more than 30 minutes on question one. 25 marks, 30 minutes. All right, so Marcus was asked to design an experiment to investigate how the solubility of potassium nitrate, that's KNO3, varied with temperature. It is known that potassium nitrate is soluble in water, but not soluble in pentane. And we should explain why the statement above is true. So we're saying that like dissolves like. So like substances will dissolve other like substances. That's the first thing we're gonna say. Like dissolves like. What does this mean? This means that, or we could add, potassium nitrate is an ionic substance. Right, there's a bit more that we can say about potassium nitrate. It's an ionic substance. It's an ionic substance, and ionic substance says tend to dissolve in water, which is a polar molecule or a polar substance. So like dissolves like. So potassium nitrate, which is an ionic substance and compound, will dissolve in water, which is a polar molecule. So one of the things that we need to say is that ionic substances dissolve in polar substances. That's a part of the like dissolve like. One thing we're going to say is that pentane is a non-polar molecule, and so would not dissolve potassium nitrate, which is a known ionic compound. All right, so we can leave it there. The only thing that pentane will dissolve would be substances that are non-polar. But potassium nitrate is not non-polar. It's actually ionic, and when you put it in a substance like water, you get it separating into its cation and its anion. So we'll leave this there. And let's see what else Marcus has to do. All right, so let us read this carefully. We don't want to miss anything. We need to interpret what the question is asking us. We need to get that from early. Now, the procedure that Marcus used to carry out the experiment to investigate how the solubility of potassium nitrate varied with temperature is outlined below. All right. So exactly 100 cm cube of distilled water was measured. Please note we're speaking in reported speech because we're referring to something that has already happened. So it's done. So it's been written in reported speech. So exactly 100 cm cube of distilled water was measured and poured into a clean, dry 250 cm cube beaker or 250 ml beaker. The beaker with the water, so we have beaker with the water, was weighed. So you'd have the beaker. Of course, it's 250 cm cube, and they pour 100 ml of water in it. So we take this beaker, and we're weighing this beaker. So that beaker has 100 cm cube of water. So we're accounting for the mass of the water. We're also accounting for the dry beaker itself. So two things we're getting when we put on the beaker with the water. We're going to get one reading, but it's accounting for two things: the water that's present and the beaker itself. The table with the water, the beaker with the water was weighed and the mass recorded in table 1 and page 6. We'll look at that in short order. While step 3, while maintaining the temperature at 10 degrees Celsius, solid potassium nitrate was added slowly with stirring until no more salt dissolved. All right, that's telling us something. When they reach the point where no more salt dissolved, then it means saturation has taken place. All right. The beaker with the salt solution was weighed and the mass recorded in table 1 on page 6 again. The experiment was repeated with 6 different 250 cm cube beakers while maintaining temperatures of 20 degrees Celsius, 30 degrees Celsius, 40 degrees Celsius, 50 degrees Celsius, 60 degrees Celsius, and 70 degrees Celsius. So we are changing the temperature each time. We're changing the temperature each time, and we're looking to see what mass of the substance we actually get dissolving. So let us go over to the next slide. So one of the things that we need to get is the readings, as figure 1 shows, the readings on the balance for the mass of the beaker and the salt solution. And this we need in grams. Now, if you want to be extra sure of what your arrow is pointing at, it's great to use your ruler to just extend the line to see exactly what it's pointing at. All right, so we need to take these readings down. We're going to put them in our tables, but let's just verify what they are first. So the one at 10 degrees Celsius, that one, first we need to look to see what this is going up by. 1, 2, that's 140, 141, 142, 143, 144, 145, 146, 147, 148, 149. So each stroke is representing one gram because this is the mass that we're taking. So for this one, we're going to put 140, 146. All right. We'll put our 146. All right. Wanted it to be a little prettier. All right, so we have 146 grams there. And we're going to continue. For 20, I think they did 2 for us. For 20, we have 148. So we'll put that here. All right. The other one, that looks like 153. Then we continue. This one seems to be pointing at 160, 1, 2, 3, 163. So we'll go with that. 163. Then we have 160, what looks like 169. All right. And we can go some more. So at 60 degrees Celsius, we now have 196. And the last one, 219. I hope we're seeing the trend already. But you don't have to anticipate any question, but we should be seeing the trend. So we have those. We can now move on to the next side, the next page. They want us to fill in those. So we're going to do just that. So for each temperature shown in figure 1 on page 5, record in table 1 the corresponding mass of the beaker and the salt solution. So we did our readings a while ago, so we're just gonna fill them in. 153. Then we have 163. Then we have 169. Then we have 196. And we have next 2, 1, 9. So the next thing they want us to do, for each temperature in table 1, calculate the mass of the potassium nitrate that was dissolved in the beaker of water and record the value in the space provided. They did the first one, so it's just know the difference between 148 and 110, which should be 38. And once we do these, we'll get our marks. Okay, and then we'll continue. This is 43. Then we have 53. Then 59. Then 86. Then 109. Right. So there we have those. So we have the temperature, check. We have the mass of salt dissolved, check. Think that will come in handy in a little while. Mass of salt is dissolved is telling us what the solubility is. The mass of a solute that's dissolved in a given mass of solvent at a particular temperature. All right, so let's go on. For each temperature in table 1, we just did that. Now we're at part D. We're gonna use the axis provided in figure 2 on page 7, and we're gonna use that to plot a graph of mass of salt dissolved against temperature. And we're going to draw a smooth curve for 5 marks. So I am going to be using a pen based on the device I have, but you should be using a pencil. All right, let's see how best we can set this so we get all the points that we need to plot. Let's look back to see what the largest point is that we'll need we will need 109. Let's see where 109 is. Okay. If we do that, we can get 109. So we're gonna go right here. Yeah. All right, so we can stay there, but we'll need some color. We'll need some red. All right, let's test to see what's happening. All right, not where we want to. Okay, much better. All right, so let's get on with the plotting of the points. We have the first one. Before we plot, we always find out what the scale is. So on the x-axis, we see where what's this now? 1 centimeter is being used to represent 5 units. On the x, 1 cm, 1 cm, can we write that is being used to represent 5 units. So we need to bear that in mind so we don't lose track of anything that we're plotting. And it's the same scale on the y-axis. 1 cm is being used to represent 5 units. So each of these 1 millimeter box each represents 1 unit. So for the x-axis, it's 1 degree Celsius, and for the y-axis, it's 1 gram per whatever the mass of the water is. So solubility is normally mass of salt per a certain mass of solvent. So we could say it's 1 gram of salt per 100 grams of water, but we'll leave it right there. So let us go. We have at 10 degrees Celsius, they did not do any plot for us. So at 10 degrees Celsius, the mass dissolved is 36. So we're at 10. 10 is here. We just need to find 36, 35, 36. So we spot it and we're going to draw a circle. We use encircle dots or small x's. So at 20 degrees Celsius, the dissolved mass is 38. So we're now at 20, and 20 will give us 38. This is 35, 6, 7, 8. So we need to dot that one, 5, 6, 7, 8. So we're gonna write it here, and we encircle it. All right, at 30 degrees, we have 43. 30 is here. We're going for 43. 41, 2, 3. All right, and then we carry on at 40. 40 is 53. 40 is here. So we need to find 53. 1, 2, 3. Should be an easy find. Nice scale. Okay. A little too heavy on that one. And then we have now 50, which is at 59. So 50, 59, 59, 1 before 60. So here we go. All right, 1 before 60. Then, okay, yours should be nicer than mine. And then at 60, we have 86, 60. We have 86, 85, 86. Right? So we're gonna get this encircled. All right, and then 70, 109. 70, 109. So that's 110 is right here. So 109 will be right there for 70. And then we need to encircle as best as the software will allow me to. Okay, so we should draw a smooth curve. So we can make this, let's try to be as smooth as we can. So here we go. Right, so we'll work with that. All of our questions that come next, we'll have to do it. It's based on this graph. So let's go on. Plotted the graph. We're going to now use the graph to answer our questions. Describe, they say using the graph. And if we look at the graph, well, part E, we can always come back to this. Part E says, using your graph, describe how the solubility of potassium nitrate varies with temperature. So we have to look, realize that on the x-axis, as we go across, temperature is increasing. So we need to look to see what is happening as we go across. How do we have the solubility responding on the y-axis based on the increase in temperature? Because the mass of the salt is what will give us the solubility. If you have a large mass dissolving in the water, then we say the solubility is high. So let us see. We see that as you go across, the solubility of the salt is increasing. Now you could say with increase in temperature, there's an increase in the solubility. So we can write that. Let's go, let's get our text up. Okay, here we go. So we could just tell them straight up as the temperature let's try. So as the temperature increases, so does the solubility of all right. Determine the solubility. Then they want us to determine the solubility in grams per 100 cm³ of potassium nitrate at 65. So we're gonna go up to the graph and we're going to find 65 degrees. 65 degrees is found here. That's 65. So what we would need now, we would need a line, a straight line. Right, so I'm gonna change the color, turn it into a blue line. So we're going to get a line that we will run from 65 and we'll ensure that this runs all the way up along that 65 path and we'll let it cut the graph. And where it cuts the graph, we're gonna get another line to go across now. So we'll use this one and we'll let it go across and we'll read out the value. Right? A little curvature in the paper there. So we'll read off this value It's 1, 2, 3, the fourth one. 1, 2, the third one. So that's 95, 96, 97, 98. So we'll work with it as 98. Can we? So we have 90, 98 grams per 100 grams of water. All right, 98 grams per 100 grams of water. That's the solubility. All right, let's see what else they're asking us to do. They want us to, so we just did that. So it's 90, we said it's 98 grams of KNO3. All right, let's get that right. Of KNO3 per 100 grams of water. Slash, you could plus slash 100 grams of water. No. 100 grams of water, H2O. This don't sue me. Not getting the H, the cross in the H, or that stick to go across. All right, there we go. All right, so they want us to use our answer to E part 2 to calculate the mass of potassium nitrate that will be precipitated out from the solution if the solution is then cooled to 35 degrees Celsius. So at 65, we had 97 as the mass that would fall out of solution. Now, if we were to cool down to 35, we'd have to check the graph for this. Let's see what the solubility then would be, and then use that value to determine what mass of potassium nitrate would fall out from the solution. So let's go back. We're going to go back and we're going to find what the solubility is at 35 degrees Celsius. So we need our line again. So we're going to put it at 35. That's where it's coming from. And we can always stretch this, carry it up the line. You should be using a ruler to do this. Then I'm gonna need another one. So it cuts here, and we of course read off our values. All right, let's see. All right, that looks like 41, 42. So we'll say 42. So at 35 degrees Celsius, the solubility is 42. So if we're going to check, if we're going to cool the solution from 65 degrees Celsius to 35 degrees Celsius, then the amount that would fall out of solution is the difference between the two. At 35, we have 42 grams of the salt dissolved, and at 65, we have 98 grams of the salt. So it would be the difference between 98 and 42. So we would just say it would be 98 grams of course, minus 40 minus 42. All right, and that's equal to, what's that equal to? 2 from 8 gives us 6. And then 4 from 9 gives us 5. So we'd have 56 grams falling out. 56 grams of potassium nitrate. All right, so we're going well. Then they ask us now, calculate the concentration of us in mole per dm cube. And I'm glad to put that there because solubility can be used as concentration. It's just that it's normally represented in terms of mass of solute per mass of solvent. And concentration is similar. Mass or number of moles of a substance in 1000 cm³ or in 1 liter, 1 dm³. They can be used interchangeably. All right, so we want to calculate the concentration of a saturated solution of potassium nitrate at 35 degrees Celsius. So at 35 degrees Celsius, we just found out that at 35 degrees Celsius, we have 42 grams. So we want to ensure that we put that in moles per dm³. So we had 42 grams. So let's get something that can capture our writing. So let's use this. So we're saying then that at 35 degrees Celsius, we have a mass of, what was it? We have a mass of 42 grams of KNO3. Need the sub 3 there. Okay, let's just say potassium nitrate is present in 100 grams of water. We can use this to work the calculation. Just need to get it back. All right, so we want the concentration. We can say then concentration. So we'll say then get a statement. Let's say mole per dm³ is what they want the concentration in. So let's see. We said 42 grams of potassium nitrate is present in 100 grams of water. Let's work on the 42 grams first. So potassium, the RFM of potassium nitrate, we need to find that before we go any further because that will tell us how many moles we have present. So potassium nitrate, we're looking at 39 plus N, which is 14, so it's KNO3, oxygen, which is 16. So based on the mass that we have right there, we can determine what the number of moles is. So let's continue with our statement. So I'm gonna say then that RFM of potassium nitrate is equal to, and we can just add up that. Not anything too tough. So that's potassium nitrate, that's 39 plus 14 for the nitrogen plus 48 for the oxygen. That's 101. All right, is 101. So if we have that, we can say the number of moles of potassium in 42 grams, we can find it because it will be 42 divided by 101. All right, so we'll get 0.42. So the concentration, all right, let's get it right. So all of 4 marks. So we've done some work already. So we'll tell them that the moles, I'm gonna say it right here. So moles of potassium nitrate in 42 grams is equal to 42 grams divided by 101 grams per mole. All right, so we have that, which is equal to, we said it's 0.42 moles. So the next thing we're gonna say then, to get the concentration, we're gonna say, hey, we know that there is in our 100 grams, So if 100 cm cube of water contain how many moles? 0.42 moles of KNO3, POTASSIUM. So we can say if that's the case, then 1000 cm cube, which is what a mole is, would contain 10 times that. Because 1000 cm cube is 10 times what 100 cm cube is, and we're using grams and cm cube here interchangeably. All right, so if that's the case, would contain 4.2 moles. Therefore, concentration of potassium nitrate at 35 degrees Celsius would be equal to 4.2 big M molarity. I'm going to leave it right there. And that's it for our first question. Follow this and we should get full marks. Please leave feedback on what you think about this workout. Feel free to book a tutorial session with Kim. We have that solution just for you. And please leave a comment on this video overall. All right, so just like that, we've come to the end of this partial work through from the January 2024 paper 2 sitting of chemistry. This has been Kev with Kim. Have a good one.